Hello everyone, it's me, Professor Aaron Albert, here again with lecture 23. Let's learn some econ. So today we're going to start talking about monopolists and how they differ from competitive markets, and we're going to show you how to solve for monopolist output both graphically and mathematically. So first thing you should do is take a moment, see if you can think up some monopolies. Think about what makes them special and what sets them apart from other industries. So hopefully one thing you remembered is that monopolists are the only supplier of a good. They are not price takers. They have no competition. This means that whatever they set as the output, that is the market output. And that means that they can set price in such a way that they maximize profits, right? Whereas a competitive firm just accepted the market price, a monopoly can choose P and Q, although not completely separately. They know there is a trade-off, and they can game their quantity in order to artificially suppress the amount in the market and keep the price high. So we're saying monopolists set Q to maximize profit. So let's think once more, what is profit? Hopefully you remember that profit, as a function of quantity, is just revenue minus cost. So going through our favorite exercises again, how do we optimize this? Hopefully you'll remember that we should be taking the derivative of profit with respect to Q, which means looking to maximize the difference of revenue and cost, dQ. So let's move from right to left because it's easy. What is dC dQ? This is just marginal cost. What is dR dQ? This is just marginal revenue. So, like competitive firms, monopolists set profit to be maximized by setting MR equal to MC. However, this is where the similarities stop. Revenue for a monopolist is slightly different. Note that revenue for a monopoly is P times Q. So if we want to look at marginal revenue, we really need to be doing some product rule derivatives. Namely, we have dP dQ times Q plus dQ dQ times P. You'll note that this is just 1. Therefore, we're going to have Q dP dQ plus P of Q as your derivative. And although you might not have guessed that you needed to do this, it is important to note that this is different from what we had as the marginal revenue in a competitive market. Competitive firms, their marginal revenue was just P of Q. Monopolists have P of Q plus this additional term, dP dQ times Q. So we should think about how this influences marginal revenue for the monopolist. First, do we think the second half of this, namely Q, is going to be positive or negative? Clearly, Q has to be positive, right? Your company can't output a negative amount of goods. Second, do we think that dP dQ is positive or negative? That is, how does quantity affect price? Clearly, dP dQ is negative. As quantity goes up, the firm must offer that product at a lower price. Therefore, this whole term has got to be less than 0. It's got to be negative. That means marginal revenue for the monopolist must be P of Q, just like it was for competitive firms, plus this negative part. So this means marginal revenue for the monopolist must be lower, i.e. their marginal revenue must be some line lying below inverse demand, i.e. lying below P of Q. So let's do some exercise to see how this works. First, let inverse demand, i.e. price as a function of quantity, be given by 24 minus Q. What is revenue as a function of quantity? And what is marginal revenue as a function of quantity? Work it out. Hopefully you note that you can just find revenue by multiplying this times Q. So our revenue must equal 24Q minus Q squared. To find our marginal revenue, just take the first derivative of this and you'll find that you have 24 minus 2Q. You will note that 24 minus 2Q is going to be the same intercept as our inverse demand with twice the slope in the negative direction. This is a general finding. Anytime you have linear demand, or linear inverse demand, you're going to find the marginal revenue to be exactly the same, just with slope that decreases twice as quickly. So here we have in blue inverse demand, and in purple our marginal revenue. Our first question seeing this might be, well, what is our equilibrium output and price? Hopefully you note that we still need cost. Why? Because monopolists maximize profit by setting MR equal to MC. We can't do that without MC. So we have MR, we need cost to find marginal cost. So let our cost be given by Q squared plus 12. If that's the case, what is our maximum possible profit for the firm? Well, find marginal cost, set that equal to marginal quantity. Sorry, marginal revenue. If our cost is Q squared plus 12, it must mean our marginal cost is 2Q. If we set 2Q equal to 24 minus 2Q, we're going to find that 24 equals 4Q, and Q equals 6. If our optimal Q is 6, what P should we select? Well, in order to find P, we need to stick that back into our inverse demand function. If we're making 6 units, 24 minus 6 suggests that our P should be 18. So this solves for us in steps. 1, find MR and MC. 2, find Q. 3, find P. Once you've done these 3 things, you can go on to find actual revenue, to find actual profits, and you can find total cost. You can find all the things once you've found Q and P. We can do similar exercises graphically, and this might seem familiar from principles. So let marginal cost, demand, marginal revenue, average cost, and average variable cost all be given as thus. Follow the same steps. First, how do we find our price? Well, we find our price by setting marginal revenue equal to marginal cost. They intersect here. Trace that up to price. It looks like our price should be 18. Next, how do we find our quantity? Well, find out what price of 18 suggests for quantity using inverse demand. 18 traced inverse demand suggests that Q equals 6. Our first question now should be, well, should the firm produce these 6 units at $18 or should they shut down? You'll note that 18 is above average cost, therefore they make money. How much money do they make? Well, 8 times 6 is 48. That's how much they pay in costs. And they take in 18 times 6. And if you look at 8 times 8, 18 minus 8, that's 10 times 6, means they profit in total 10 per unit, i.e. $60 total. So they come out ahead by $60. At what price should they shut down? Well, it seems like the lowest average cost is around here, so it looks like if price ever got below about 7, they should shut down. So yeah, somewhere around $6. It looks to me like the average cost is actually around 7. Do this one on your own. Let P be given by 700 minus 11Q. Let cost be given by 2B plus 220Q. And solve for average cost, marginal revenue, marginal cost, price, quantity, and profit. Let me know how it goes. All right, let's see how you did. First note that our inverse demand is given by 770 minus 11Q. Our cost is given by 2B, which is just some constant, plus 220Q. You'll note our average cost is just going to be 2B divided by Q plus 220 divided by Q. What is then our revenue? Well, our revenue should be our inverse demand times quantity. So we're going to find 770Q minus 11Q squared. If we take the derivative of that, we should find 770 minus 22Q. How do we find price and quantity? Well, we're going to look at where marginal revenue equals marginal cost, i.e. when 770 minus 22Q equals the derivative of our cost function, i.e. it equals 220. If you do this, that suggests our Q should be 25 and our P should be 495. How can we find our profit? Well, our profit is going to be our average cost at Q equals 25. That ends up being 300. And then you subtract that from our price of 495 and multiply it times 25. So that means profit will be this whole region here. What about our total cost? Well, our total cost is going to be the region below where average cost intersects our quantity. That'll be here. That's all we have time for today. Thanks so much. See you next time.